Hello. Hello.
Boleh. Assalamualaikum,
Hello.
Prof.
Walaikum salam. Can you
Marsha.
hear me, please?
Welcome to, yes, yeah, it's so clear. Can we start the lecture today?
Okay. Can you hear me, please?
Yes, that's clear.
Okay, okay. Just a moment. I have to. Actually, I have to put the background, right?
Oh,
Background of
okay.
your, but I don't know how to do it.
Okay, it's never mind if you couldn't
Can you
use
guide me?
it's never mind if the virtual background cannot use in the in your screen, Professor.
Just a moment. Hello.
Ya, halo Profesor. Oh, nggak bisa ya. Suara Ibu kedengaran? Kedengaran, oh berarti profesornya ya.
Change theme, full screen speaker. How to put the background? Because normally we use Google Meet, so I'm not much used with
Zoom.
Zoom.
Okay, you can start the video button in the left of your screen
Uh-huh.
video.
Okay, okay, okay.
Okay, and then
Adjust,
adjust
adjust
background.
background and effects,
Yes.
right?
Yep.
Okay, okay, okay. Select. Desktop.
Add image or add image in the
Yeah,
blue
yeah,
button.
I'm,
Yes. Okay, okay.
I'm doing.
Yes.
It's okay
Okay.
now?
Yes. It's okay. Can
Okay.
we can we start the lecture now, Professor? Can we
Yeah, it's
start?
fine. I will
Okay.
open my presentation.
Before maybe we have opening from the MC.
Okay, okay,
Okay.
okay.
Okay, please welcome operator.
Hello, good all the participants, also the speaker.
Please speak loudly.
Okay, thank you. Welcome back with me, Helen, as your master of ceremony. Well, how was your break time? I guess it's pretty good to have a dialysis meal, right? I think your participants are ready to continue the course. The next second course will be about green extraction and enrichment of bioactive natural products for their application in phytocosmetic and aging-associated diseases. Will be brought by Assistant Professor Muhammad Ajmal Shah from the MPhil PhD from Hajara University, Pakistan. I believe this session will be very interesting, and of course, this session will be moderated by Apotheker Lisda Rimayani Nasution S.Farm MSc. Miss Lida is also one of the young lecturers in the Faculty of Pharmacy, Universitas Sumatera Utara. She has many publications in the pharmaceutical analysis field and also some experience in the apothecary organizations. So to Miss Lida, please welcome.
Thank you, Helen, for introducing me. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, all our participants. First of all, I would like to say thanks for having me as a moderator today. And also thank you very much to International Summer Course Pharmacy Universitas Sumatera Utara 2024 for organizing this event. And to all the admirable participants, welcome to third course. I am Lisda Rimayani Nasution, will be guiding you in this session. Before we begin, let me remind you for one thing, this session is divided into two parts. The first one is lecture. We have a speaker today who are interested in green approach of bioactive constituent. Good afternoon, Mr. Muhammad Ajmal Shah. Please welcome. And in the second part,
Thank you.
And the second part, we have Q&A session. I hope you can enjoy and giving focus on the third lecture. So if you have questions, you can submit into the Q&A room. Dear all participants, let me introduce our speaker in the third lecture today. We will enjoy course from Assistant Professor Muhammad Ajmal Shah from the MPhil PhD. He is a lecturer at Department of Pharmacy, Hajara University, Mansara, Pakistan. He graduated from Faculty of Pharmacy, Federal Urdu University of Arts, Science and Technology, Karachi, Pakistan, at undergraduate and postgraduate program. He graduated in Pharmaceutical Science from Department of Pharmacognosy and Pharmaceutical Botany, Faculty of Pharmaceutical Science, Prince of Songkla, University Hatian, Thailand, at PhD program. His research expertise and interest about bioactive constituent and green preparation. He also has more than 100 publications in well-reputed international scientific journals. He also has 2 patents. The first is about green preparation of berberine-rich extract. And the second one is about a novel polyherbal formulation for diabetes treatment. Mr. Muhammad Ajmal Shah also get research grant about green technology from Punjab Higher Education Commission, Pakistan. And he has also had more work experiences, awards, and achievements. He also has contributed 60 book chapters in various books published by Elsevier, Springer, and CRC. So we know that our speaker today is an expertise in green approach of bioactive constituents. Dear all participants, without delonging for a long time, perhaps we can make a start the third lecture with the topic green extraction and enrichment of bioactive natural products for their application in phytocosmetic and aging-associated disease, which will be delivered by Assistant Professor Muhammad Asmausa from DMPhil PhD. So our honorable speaker, please welcome Assistant Professor Muhammad Asmausa. Time is yours.
So I have to start, right?
Yes, please welcome, Mr.
Okay. Bismillahirrahmanirrahim. Assalamu alaikum, everyone. First of all, I'm very thankful for the faculty and organizer who provided me the opportunity to talk with you people regarding my specialty and my expertise in the green extraction and enrichment of bioactive natural products for their application in phytocosmetics and aging-associated diseases. So you can hear me clearly?
Yes, Mr. It's clearly.
Okay, but I can't hear you clearly. Your voice is very low. I don't know why.
Okay, sorry, Mr. It's loudly.
Yeah, it's fine. Okay. Okay, let's proceed.
Yes, Mr.
Just a moment. Okay, so in this talk today, I will talk about green extraction, that what is the concept of green extraction and why microwave assisted extraction is considered to be an experimental procedure for the green extraction, as well as I will also give you an outlook about the use of pharmaceutical excipients as extraction solvents to avoid the toxic solvent, organic solvent. And also I will present some data about our research in which we have proved that the enriched bioactive compound enriched extract has same biopotential is having by the pure isolated compound. So let's proceed. So the first is the herbal extract. I think the theme of this course is about herbal and cosmetics, that how we can incorporate the natural compounds and natural extract, particularly the herbal extract, in the preparation or in application of cosmetology or cosmetics. So first of all, we will see about the advantages and disadvantages of the herbal extract. So in the slide, you can see that the herbal extracts are very simple to prepare. They are low cost because we are getting them from the natural sources. So they are easy to obtain, and also because of their diverse chemical nature, because you know that in a particular extract of any plant, there are variety of compounds. So they exert individual as well as synergistic biological activities in combination. So there is a opportunity for synergism. You know that synergistic activity means that, for example, if you are giving some compound for some therapeutic effect. So a single compound can give you a lesser effect if you are give in combination with another compound of the same nature or of the different nature. They exert more effect in combination rather than their individual effect. On the other hand, herbal extract have some disadvantages, like they have unsatisfied appearance. Maybe you have seen many extracts, if you have prepared in the laboratory, their appearance is not good. They are sticky in nature, their color is not good. Another important parameter is their stability. They are not much stable if you are not putting them or store them under standard condition. So they sometimes lose their stability. And in some cases, you cannot use them for acute condition like for immediate effect, but they have slow and steady effect. So that's why they have less efficacy. So now the question is how to prepare an appropriate herbal extract. There are different classical methods for herbal extracts preparation, like maybe you have studied about maceration, percolation, and some other classical techniques. But recently, the trends have been changed because we are concerned with the environment, we are concerned with the biodiversity, and we are more concerned with the environmental safety. So the world is actually the revolution is regarding the green concepts. So regarding other processes, also the extraction of plants or other material, there is a concept of green extraction. So what is the green extraction? Green extraction is actually the process or combination of processes in which we use renewable resources and alternative solvents. What does it mean? Renewable resource means, for example, if you are using the complete plant, or maybe if you use the part of the plant which harm the plant, like for example, if you are using the root of the plant, so once you will collect the root of the plant will disappear from the planet. If you will do it continuously, the plant will disappear from the planet. Instead of the root, if you are using a renewable part, like you are collecting the leaves, you are collecting the flowers, or you are collecting the fruits. So these are the renewable parts. If you are if you collect it in one season, so in another seasons you can get it again. So the most important parameter for the green extraction is your raw material must be from renewable source. Another point is alternative solvents. Instead of using toxic solvent like hexane, chloroform, methanol, these are very toxic. And of course, after extraction, you have to evaporate them and you have to discard them. So ultimately, in the sink of your laboratory, it goes into the environment. So avoiding the toxic effect of these organic solvent, you can use alternative green solvent, which I will discuss in the next slides. Another important parameter is you have to ensure the safe and high quality extract. The extract which you get from the green extraction process ensure the safety as well as the quality of the product. And finally, reduce the energy consumption. So as compared to the classical extracts, if you prepare the plant extract by green method, you can reduce the energy consumption and ultimately it will reduce the cost of the product and you will get an economical and low cost product, which is also an important parameter. There are 6 principles for the green extraction. Number first is you have to use the renewable source, as I earlier discussed, that you have to use that part of the plant which can be regrow in the next season. Like for example, if you use the root, so the root cannot be regrow, but it will harm the plant. And finally, if you will use continuously the root of one plant, the plant will disappear from the planet. So you have to select the renewable part like the leaf, the flower, or the fruit. The second is the byproduct. Alternatively, you can also use the byproduct. For example, we are using a variety of vegetables and fruits in our home. So the byproduct are the waste material which we are throwing in the garbage. Sometimes these waste material can be used as a source for the preparation of herbal extract. So if your raw material is a byproduct like the peel of the pomegranate, the peel of the mangosteen, the unnecessary parts of the vegetables and fruits. So these are the byproducts, and this is also one important principle. The utilization of the byproduct is one of the important principle of green extraction. The third one is the alternative solvent. Alternative solvents are the green solvents. Green solvents are those solvents which are bioconsumable. Bioconsumable means those solvent which you can which you are which the human or animal can use without any toxic effect. Like for example, the most green solvent and the bioconsumable solvent is water. But of course, there is a point of polarity. The water only dissolves the polar compound. So in case of non-polar compound, you need non-polar alternative solvent. So you know that there are different oils like sunflower oil, like peanut oil, like olive oil, and some other synthetic oils you can use which are green and which are bioconsumable. So you can use them for the extraction of non-polar compound. So this is also one of the important principle of green extraction. The fourth is you have to reduce the energy consumption. So this is also this depend on the innovation, that how you can innovate the equipment or the process of the extraction. So this is also an important principle of the green extraction. Fifth is you have to reduce the unit operation. So the most important is you have to think, you have to be creative, that what should be the one stage process or two stage process which can reduce the unit operation. So ultimately it will reduce the time, and ultimately it will reduce the cost of the labor, and finally the cost of the product. And the last thing is all the material which you are using in the extraction process or the enrichment process should be or must be biodegradable. For example, if you are using column chromatography, in column chromatography, if you are using silica gel, so silica gel is not biodegradable. So if you are using silica gel, this is not a green process. Instead, if you use some polymers like Emberlite or some other Sephadex, and there is another Dione. These are different resins, polymers, which are biodegradable in nature. And if you are using them in column chromatography for the extraction or for the enrichment, so of course, this is also one of the important principle of the green extraction. So why we select the microwave assisted extraction as a green extraction method? Do you have idea about microwave or not? Of course, the microwave oven you are using in the kitchen, that is the microwave. So you are using in the kitchen for making hot your food or making warm your food. But this microwave can also be used for the extraction of any plant material or for the preparation of herbal extract. So the principle of microwave is if you compare it with the conventional heating, like if you are making a tea on the stove of the gas or something else, so you have to turn on the fire, and the fire will give the heat from outside, and the heat will move from outside to the inside. Instead, in microwave, when you are heating something in microwave oven, it actually generates heat inside the material, and the heat moves from inside to outside. So this is the difference between conventional heating and microwave heating. So in conventional heating, actually, you heat first which you don't want to heat, like the vessel, the utensil, heat first, but you don't want to heat it. You want to heat the material which is in the container. But instead, in microwave, you heat first what you want to heat. So the material get heat first because the heat generate inside. This is the mechanism of the microwave heating procedure. Like there is a ionic conduction and dipolar polarization, and together they produce a microwave field and it produces an energy, and the amount of the water or amount of the moisture within your substance actually generate the heat inside the material, and it increase the solubility of the compound that is present in the plant powder. So this is another comparison of conventional and microwave heating. So the heat transfer is actually in conventional heating, the external heating source, you have to use external heating source, but in microwave heating you have internal heating source. The heat flow in conventional heating is from outside to inside, but in microwave it is from inside to outside. So the energy loss is more in conventional heating, but in microwave, the energy loss is less and it is more efficient than the conventional heating. So this was the concept of microwave extraction, that how microwave work. Whenever you need to extract some plant material, uh, you have to know the boiling point of the solvent which you are using for the extraction, and you have to optimize the time duration for the boiling of that solvent in microwave. So you have to keep the thermometer, you have to turn on the microwave, and when it start boiling, you have to check the thermometer that if it reached to the boiling point of the solvent, so that is the maximum time that you can utilize for the extraction of any plant powder. Simply you have to take the plant powder and you have to put it in the solvent, then you have to keep it in the microwave oven, and uh, then you have to turn on the microwave on a specific power and for specific time, then close, open the door of the microwave for removing the fumes and vapors of the solvent, then do it again. You can do 2 or 3 cycles of the microwave heating, and after that your extract is ready. Then you can filter your extract, and then you can further proceed for utilizing your extract. So how about the concept of pharmaceutical excipients for the preparation of herbal extract? As I told you that the organic solvents like chloroform, methanol, hexane, and dichloromethane, these are very toxic to the environment. So instead of utilizing the organic solvent, we can also use pharmaceutical excipients as a solvent for the extraction of any plant material. So what are the pharmaceutical excipients? You know already, because you all are almost pharmacists. You know that pharmaceutical excipients are those substances which we are using uh, to shape the active ingredient in a particular dosage form. It can be solid, it can be semi-solid, and it can be liquid. So you can use these solvents or pharmaceutical excipients for as a solvent of extraction. I will present an example of mangosteen. You know, this is very popular fruit in tropical region. We don't have it in Pakistan, but in Indonesia and in Thailand, it is very popular, and it is normally known as queen of the fruit, right? The botanical name of the mangosteen is Garcinia mangostana. Okay, and the active compound in the peel of the mangosteen is alpha mangosteen. Alpha mangosteen has been reported for its antioxidant, wound healing, anti-inflammatory, and antimicrobial potential. So in our lab previously when I was doing PhD at Thailand, one of my colleague was working with this material, and he determined the suitable solvent for extraction of alpha mangosteen. You can see in the table that dichloromethane has the highest yield of alpha mangosteen content. So it means that dichloromethane is actually a non-polar solvent. So it means that alpha mangosteen is more non-polar. It means that alpha mangosteen is more water non-soluble. So instead of this toxic organic solvent, because dichloromethane is an organic solvent and it is very toxic. If you will use it continuously and you will throw it in the environment, so it may harm other environmental it may harm to the animals, to the plants, and it can cause environmental pollution. So what can be the alternative solvent that has the similar polarity is having by the dichloromethane to extract alpha mangosteen? Our colleagues studied different pharmaceutical excipients and they optimized the extraction of alpha mangosteen in various pharmaceutical excipients, like you can see in this table. The mineral oil, the isopropyl myristate, stearyl alcohol, cetyl alcohol, and dichloromethane. And if you compare the properties of the solvent with the dichloromethane, these are actually the pharmaceutical excipient: mineral oil, isopropyl myristate, stearyl myristate, cetyl alcohol, propylene glycol. These are the pharmaceutical excipient. So these can be known as green solvent because these are bioconsumable and these are green. And if you compare cetyl and stearyl alcohol, so you can see that solubility in water of dichloromethane is almost similar to stearyl alcohol and cetyl alcohol. So we assume that based on the solubility in water factor, we can use stearyl alcohol and cetyl alcohol in replacement of the dichloromethane, which is a toxic organic solvent. So what our colleagues did, they actually use stearyl and cetyl alcohol. You can see in this slide, these are the cetyl and stearyl alcohol, and in pharmacy, cetyl and stearyl alcohol are used as a cream base. So we thought that cetyl and stearyl alcohol has the similar polarity. So we extracted the mangosteen powder, mangosteen peel powder directly in cetyl and stearyl alcohol, and we got it successfully because by extracting directly in the cream base, like in cetyl and stearyl alcohol, we have exempted this stage. This is actually the evaporation stage, which we normally do when we extract the plant material in organic solvents. So this has been skipped. So this is like the principle of the green extraction. And we got a direct cream or oral base formulation that has alpha mangosteen, and that has been prepared from the byproduct of the mangosteen, that is the peel of the mangosteen. And it has been analyzed by HPLC, and we found that in different solvent, like in dichloromethane, you can see the yield of the extract is 15% and alpha mangosteen is 0.1. But interestingly, in stearyl and cetyl alcohol, the yield or the content of the mangosteen and also the yield of the extract is equivalent to dichloromethane, and the content of the mangosteen is more than the dichloromethane. So from these results, we presume that cetyl and stearyl alcohol can be suitable green alternative solvent instead of dichloromethane, and also we can incorporate them directly in any topical or cosmetic, medicated cosmetic formulation. These are the structure of cetyl and stearyl alcohol, and this is the optimization procedure. In our lab at Thailand, they have optimized it and they have prepared it for industrial purpose. And this is like the big microwave apparatus they have in their laboratory. And nowadays, this is a product which is patented by my supervisor and my boss. He patented it, and it is a commercialized product in the market of Thailand. Because alpha mangosteen, as I previously told you, that alpha mangosteen is a potent anti-inflammatory, antimicrobial, wound healing, and antioxidant properties. So it can be used for anti-aging purpose, it can be used for wound healing purpose, it can be used for inflammation, and it can be used for antimicrobial properties. I hope you got some idea now that how you can take the herbal powder to use them for the preparation of topical formulation, either gel or cream or something like that. And you can use the pharmaceutical excipient or solvent directly for the extraction of that plant material. Then you can standardize them by using the HPLC to know the exact quantity of the active compound. And in this way, you can prepare a standardized herbal, pharmaceutical, or cosmetic product using the green extraction procedure. Now, the second part of my talk is about the preparation of active constituent enriched extract. In natural products, in pharmacognosy and in natural product, you know that the compound which are present in the plant material or in the natural source are normally very less in amount. If someone has done work with the phytochemistry, so whenever you are isolating the phytochemicals and the active compound from the plant, they are normally very less, like in microgram or in milligram. So the question is, if you can get a very good compound from the plant, how can you commercialize it? Because it is in very, very minimum quantity. For commercialization, you need a huge amount of the compound. So either you have to go for the synthetic chemistry, but if you still insist that you want to use the natural one, so then you can work in the area of active constituent enrichment, or in the you can prepare the active constituent enriched extract using green approaches. I will present an example of Berberis lycium. One of my PhD student has worked on this plant, and this is very common plant in Pakistan. It is also it is a kind of berry, and the fruit of this plant is we consume it. It is a fruit, and the medicinal part of this plant is the root bark. You can see in the picture there are some roots in the picture. So the root bark is very potent. And why it is potent? What is the responsible compound present in this plant? That is berberine. Maybe you have studied in pharmacognosy. Berberine is an isoquinolone alkaloid, and it has a variety of therapeutic activities, like it can be used as anti-diabetic, it can be used as antimicrobial, it has the potential against cancer, it has the potential against, it is also an immunomodulator, it is a very potent wound healer, and it is also neuro protective agent. So the problem with berberine is commercially available berberine is very expensive. If you buy berberine from the market as a molecule, it is very expensive. So how can you get the natural berberine? So you have to, if you will isolate it from the plant, it is very less. You cannot commercialize it. So the commercial expenses, the multi-step process, the toxic solvent, if you do isolation, you will have to use a huge amount of organic solvent. So that has an environmental impact. And of course, the time and energy consumption during the isolation of the berberine may ultimately have a high cost of the final product. We did a survey and we found that until now, the maximum amount of berberine content in literature is obtained 13.39 weight by weight % using HPLC. And they use succinate apparatus for extraction, and it is obtained from the root bark. So what we did, we thought that if we prepare berberine rich extract, so we can use it as a bioequivalent of the pure berberine, which is commercially very expensive. So how we prepared berberine rich extract? Like we dig the plant and we collected the bark of the plant. Then we dried at 60 degrees C for 48 hours. Then we proceeded for microwave assisted extraction because we are believing on green extraction principles. And how we proceeded, you can see in the process, we use the power of the microwave as a 100 watt. We did 3 cycles and each cycle has 6 minutes. We kept the powder, 300 gram of powder of Berberis lycium powder in 1500 ml, and we extracted it 2 times, and we turn on the microwave for 6 minutes and then turn off the microwave after 6 minutes. So it means that we did 3 cycles. After extraction, we did filtration, and this filtrate has been passed through the dione, which is a synthetic resin and which is used for the enrichment of the compound. We use dione column at a flow rate of 20 ml per minute, and the solvent which we used for the enrichment was 30% to 70% of ethyl alcohol in water. So ethyl alcohol in water is also be considered as a green solvent. After this, we did evaporation. And finally, we got berberine rich extract. BRE means berberine rich extract. We analyzed this berberine rich extract. You can see the chromatogram of both BRE and pure berberine. And we calculated in crude extract before enrichment, the content of berberine were 32%, 32% weight by weight. And after enrichment means after this stage, after passing through the resin column, the amount of berberine increased from 32 to 58%. So our berberine rich extract contain almost 60% of berberine as an active ingredient. So we thought that this rich extract can be used as an alternative for the replacement of the pure berberine, which is available commercially but very expensive. So this is our first article we published in Journal of Food Chemistry. In this article, we have reported that how we prepared berberine rich extract, and then we tested this berberine rich extract in comparison to commercially available berberine for its anti-inflammatory potential. In the results, we found that on the same doses, both berberine-rich extract showed very promising effect in comparison to pure berberine on the dose of 25, 75, and 125 milligram per kg. This is another article. In this study, one of my master student did this work, and we reported that the berberine-rich extract has similar or bioequivalent effect to the pure berberine, which is available commercially for its anti-Alzheimer effect. So this study showed the therapeutic activity of berberine-rich extract for the use of Alzheimer. In this study were conducted on rats and animals, and we have analyzed 3 parameters, like we did behavioral studies, we did biochemical studies, as well as we did gene level studies. And we found in all studies that at a dose of 25 milligram and 50 milligram per kg, both berberine-rich extract and berberine showed bioequivalent and similar therapeutic effect in this Alzheimer rate model. This is another study we did for the comparison of antimicrobial effect of berberine and berberine-rich extract, and we found, you can see in the table, that on similar doses of berberine and berberine-rich extract, we almost got inhibitory effect against all pathogenic bacteria like Proteus vulgaris, aeruginosa, Escherichia, pneumonia, MRSA, and Salmonella typhi. In anti-cancer potential, we have compared berberine and berberine-rich extract, and we found that berberine-rich extract has a similar bioequivalent effect to berberine on the same dose. We also perform MTT assay to study the safety of the berberine-rich extract, and we found that up to some level, or at the IC50 level of the berberine-rich extract and berberine, it has almost similar inhibitory effect in both cell model like A549 and MDA MB231. In wound healing effect, similarly, berberine-rich extract shows similar bioequivalent effect that having by the berberine. In anti-diabetic study, which is recently published, we have induced the diabetes by using streptozotocin model, streptozotocin injected in rats, and then we treated both with the berberine-rich extract one group and one group with the berberine, and we found that both berberine and berberine-rich extract have bioequivalent anti-diabetic effect in the rat model. Finally, based on our studies, we have filed a patent about berberine-rich extract because we prepared it first time by using green processes and green extraction and green enrichment, and we filed a patent to the IPO, Intellectual Property Office, Pakistan, and we claim that berberine-rich extract is a natural alternative which is cost effective, have lower cost of preparation, and it is a potential alternative to commercially available expensive berberine. So now I will conclude my presentation. So in this presentation, what I taught to you, the first is how whenever you want to work on specific herb, for the preparation of rich extract or green extract, the first and important thing is you must know the major or marker phytochemical. That what is the major phytochemical of that herb or that plant? It is glycoside, or it is alkaloid, or it is tannins, or what? So you should know the chemistry and the type of the compound, which is the major compound. Marker means the major based on the concentration as well as based on the activity. So we decided as a major or marker compound. Then after that, if you know the chemistry of that compound, you should know that either it is polar or non-polar. So based on the polarity, you have to decide the suitable solvent for the extraction. Then after that, once you know the type of the compound, the polarity of the compound, the type of the solvent, then you should proceed for the microwave assisted extraction by optimizing it properly. You have to optimize the extraction protocol, like you have to optimize the powder amount, the solvent amount, the process, the time duration of the microwave extraction. After that, you have to compare the polarity of the green and bioconsumable solvent or pharmaceutical excipient, which you intend to use for the preparation of the green extract. And after all optimization and hard work, you can get your product by green process. So this was all about for today, and hopefully for the next year, your professor has told me that maybe I will visit your university. So we can do these things practically too in your lab as a workshop or something like that. So thank you for your attention. And if there is any question, so you are more than welcome.
Okay. Thank you, Mr. Muhammad Atmawsa. What a very interesting and insightful presentation. Yes. Can you hear my voice?
Yes, I can hear now.
Okay, thank you, Mr. Muhammad Atmawsa. What a very interesting and insightful presentation about green extraction and bioactive compound enrich, yeah, especially berberine and this extract. Now we are going to Q&A session. We will remind you again that you can submit your question in that column with the format name _ university _ question. Okay, we will start from first question.
So Angeline want to ask the question. She should unmute the mic.
Yes, is my audio clear? Am I audible?
Yes.
Yeah, I can hear you. Please proceed.
All right, thank you for the opportunity. My name is Angeline Paulina Purba. I am from Universitas Sumatera Utara. So my question is, you mentioned earlier about the 6 principles of green extraction, one of them being the alternative solvent. So I was wondering, Professor, is ethanol considered a green solvent? Because I have read a lot of articles that stated that ethanol is considered as one of the green solvents, whereas ethanol is alcohol. And as far as I'm concerned, alcohol is harmful towards the environment. So do we actually consider that ethanol is a green solvent? And if we do, how do we actually differentiate which solvent is toxic and which solvent is not and can be utilized as a green solvent? That's it. Thank you.
Okay. That is a very good question, that how we can know that which type of solvent is green or it is not green, right? So the most important point is, if a solvent is bioconsumable, you know bioconsumable? If you can consume it, if you can drink it, or if you can add it in your food, or if you can add it in your medicine. So in my opinion, that is bioconsumable and that is green solvent. So the most important green solvent is water, the major one. But regarding the polarity, we cannot extract every compound in water because the non-polar compounds cannot be extracted in water. So you have to choose the non-polar solvent. Regarding the ethanol, ethanol is a green solvent because it is a bioconsumable. You can see many people, they drink alcohol, you know, in the form of beer, in the form of whiskey, vodka, and many. Also, apart from the drinking, many preparation like in your medicine, if you are a pharmacist, so you must know that elixirs are normally alcoholic preparation, right? And also in some oral preparation, like you use somogel or some other kind of gel for oral processes, so you can see that it contain alcohol, because alcohol, at a time, alcohol gives you two effects. It is a soothing effect. It gives you soothing effect. It is antimicrobial, as well as it is anesthetic, local anesthetic. So it gives you analgesic effect. So in my opinion, there is a problem with the continuous consumption of alcohol. You cannot consume it for a long time in huge amount, but still people are using it. That is another debate. If you compare other, like for example, if you are taking oil as a green solvent, but still if you will use oil for a long time, if someone has hyperlipidemia or cholesterol, so they cannot use oil. So it doesn't mean that if they cannot use oil, so it is not green solvent. In general, if some solvent can be orally consumed, it is known as green solvent. Okay, got it?
Got it, sir. Thank you for the insightful answer.
Welcome.
Okay, thank you.
I hope I didn't get long time, right? I was watching at my mobile phone and to try to finish it within time.
Okay. Okay, we go to the next question. Please raise your hand if you have a question before we read the question from column chat.
Your university is in Jakarta?
Not Sumatra, Mr.
It is far from Jakarta, right?
Yes.
Because
About
this year I am visiting 3 universities. On 24th of August, I will go to UMS Solo, Surakarta. I will stay there for 1 week. Then I will go to Ondip Semarang for 2 weeks. And after that, I will come to Jakarta for 1 week to Pancasila University.
Medan.
So if someone is interested in talking, like listening to my workshop or presentation over there, so you can join. No problem.
Okay, sir. I will read question from chat column. The first question it's from Kevin Panjaitan, Universitas Sumatera Utara. The question is, if we use another extraction method, will the percentage of berberine we get be the same? What the reason we use MAE instead of maceration method? And can we use MAE for extraction of all plant? Is it clear, sir?
Okay. I'm reading. Okay.
Okay.
It is in the comments, right?
Yes, the Kevin Panjaitan.
The first is just a moment.
The first question from Kevin Panjaitan.
Wait. If we use extraction method, will the percentage of berberine we get be the same?
Yeah.
What is the reason we use microwave assisted extraction instead of maceration, and can we use MAE for extraction of all plant? This is very good question. Kevin has asked the question about why we use microwave assisted extraction. Of course, if you will change the method, so the content of the compound will be changed. For example, if you will, I have shown you in this slide Just a moment. You may see in this slide. In this slide, you can see different plant material, different methods, maceration, percolation, Soxhlet, maceration, even MAE. So you can see the contents are very low, but we optimized the method and we got more content. This is the one part of the question. Now I will see. So the first part of your question is, will the percentage of berberine we get be the same? No, never. Because different methods have different principle and different solvent system. So if you will change the method, the content of berberine will be changed. Another part of your question is, what is the reason we use microwave instead of maceration method? And can we use MAE for all plant? For the last question, yes, you can use microwave assisted extraction for all plant, for any kind of plant, but the important thing is you must know that which kind of compounds present in your plant, either polar or non-polar. Once you know the nature of the compound, then you decide the type of the solvents and you select the green solvent, and then you can optimize the power of the microwave, the amount of the solvent of microwave, powder to solvent ratio, and all these things you can, in the final results, you can have optimum condition, that what are the best condition under which you can extract your plant material by MAE. And why we use MAE instead of maceration? Maceration is a classical method. In maceration, you have to soak the plant material for a long time. So you need more amount of solvent as compared to microwave. The first point is the amount of the solvent. You know, you have to pay for the solvent. So if you will consume more solvent, so it will increase the cost of the product. The second is, you have to keep it for a long time, for many days or sometime weeks, and you have to change the fresh solvent again and again. So as well as the increased amount of solvent, you have to consume more time and more energy, more labor. So ultimately, the cost of your product will be more if you are using the classical method like maceration instead of microwave. The next question is asked by Monica. Does the use of natural product produced through green process have any disadvantage? Of course, every procedure, every innovation, and every new things or novel thing have some, they have advantages, but they also have some disadvantages. For example, for if you will not be aware of using microwave, and if you will not optimize the condition, the time duration of the solvent and the extraction, so it may make some harmful effect, or sometimes it may deteriorate the compound. So everything has advantages as well as disadvantages. But in this case, microwave assisted extraction and green extraction has more advantages than the classical one. Another question asked by Rahmi Fozia. She's asking, as we know, the use of green extraction, specifically MAE, offers many advantages compared to conventional method. Are there any environmental impact associated with the use of MAE? How does microwave assisted extraction compare to traditional extraction techniques in industrial application? So again, it depends. This is a new technology. You have to purchase a new equipment for this, because you cannot use the household microwave in industry. If you are using it for industrial purpose, you have to buy a large microwave apparatus that can give you a large amount of the extract. And the other things are I discussed already in the previous question, that it offers more advantages than the classical. And of course, there are still some environmental impact, but as compared to the classical techniques, we can reduce the environmental impact as much as possible by using the green procedures. Anyone else? I think I have answered all the questions. Another is, what challenges might arise when Sabina asked, what challenges might arise when optimizing the extraction protocol for green extraction method and how can they be addressed? For any type of analytical procedure, extraction procedure, you have to optimize all the conditions. You have to optimize the amount of the solvent, the type of the solvent, which type of solvent should be used, what amount should be used, what plant powder and solvent ratio should be used, what time duration should be used. So of course, initially you may face some challenges, but if you proceed with step-by-step optimization with the proper results and conclusions, finally you can get the best conditions to have a maximum effective procedure.
Okay, thank you, sir.
Anyone else?
There is some question in that column, sir. If you, I will read the question from Dami Permata Putri from Universitas Sumatera Utara. In your article,
Speak loudly, please. I cannot hear you, believe me.
Okay. In your article, sir, given that
Yeah.
the complex interplay between oxidative stress, neuroinflammation, and neurodegenerative process, how does the berberine enriched extract modulate specific signaling pathways or molecular targets to simultaneously address
I
both?
didn't understand your question. Please ask again.
Oh,
This one?
this from Dami Permata Putri, sir, in chat column.
Okay, you in comment?
In chat.
Okay, this one. Okay.
Okay, from
In your
Dami.
article, sir, give us the complex interplay between oxidative stress, neuroinflammation, and modulate specific signaling pathways or molecular targets to simultaneously address both oxidative damage and neuroinflammation induced by aluminum chloride. Furthermore, considering the potential off-target effects and the blood-brain barrier permeability of berberine, what are the long-term implications and possible adverse effect of using extract as a neuroprotective agent, particularly in the context of chronic? Okay. For studying the detail, I may share the link of this article, or you may see here the type of the article. You can download this article and you can study the detailed methodology that how we performed the effect of berberine rich extract in oxidative damage and neuroinflammation. Regarding the blood-brain barrier study, it is linked with the pharmacokinetics of berberine. We did not perform the study on pharmacokinetics, either computational or in view. In future, we may study the pharmacokinetic profile of the berberine, and we can know that how it can affect the body or how the body can affect the drug. And another thing that is concerned with the toxicology, so we also didn't perform yet about, but there are some report that up to some level of the dose, the effect of the extracts are tolerable by the body. But of course, your question is very valid, and there is a need of further study to check the pharmacokinetic profile of the berberine as well as the toxicological profile of the berberine, that either it is safe or not safe. So of course it needs a long-term study, acute, subacute, chronic studies, and then maybe if it is suitable, so the clinical trials, and in clinical trials we can see that it is suitable or not. I hope it's fine now. Is there anyone else?
There is the last question, sir, from Devindi Rodrigo, University of Colombo, Sri Lanka. The question is, how do green extraction techniques align with global sustainability goals? And what role does policy play in promoting the adoption of green technologies?
Yeah, of course, you can see the green concepts are actually revolve around the sustainability goals. I don't exactly remember that which goals lies, but if you see the 6 principles of the green extraction, so from each principle of the green extraction, you can interlink the particular principle of the green extraction with the particular sustainability goals.
Okay, thank you, sir, for the explanation. This is the last question from participant. And no, we apologize the question that we couldn't answer in this session because we are limited by the time. Thank you very much to our speaker and to all participants who have been paying attention and with enthusiasm from our lecture today. I believe that all of us have got a better understanding the green approach of bioactive compounds and rates. Finally, thank you for your kind attention. Never forget both to learn, stay safe, stay healthy, and I would like to hand this event back to the Master of Ceremony. And thank you so much to Mr. Muhammad Ajmalsah. Assalamualaikum
Terima kasih.
warahmatullahi wabarakatuh. Terima kasih.
Waalaikumsalam.
Thank you, Ms. Lisa, for moderating this session. This is very eye-opening studies. I hope that all of us were able to gain new insights. And then, to express our gratitude, we would like to award a certificate to our speaker and moderator. For the first one, we would like to invite the Honorable Assistant Professor Muhammad Ajmal Shah from the MPhil PhD. And we are pleased to have Apotheker Mariani SSC MSc, the third Vice Dean of the Faculty of Pharmacy, Universitas Sumatera Utara, to deliver the certificate.
Assalamualaikum, Dr. Ajmalsah.
Waalaikumsalam. Thank you very much. Terima kasih.
Terima kasih. Congratulations on your presentation that was very full of spirit. Your presentation. Thank you very much.
Thank you
On
very
behalf
much. And
of-
I talked with Dr. Dini. Maybe next year I will visit your university. This year I am visiting Undip, UMS, and Pankisala University. For 1 month, I'm coming. At the end of this month, I'm coming to Indonesia. Maybe next year we can plan some activities at your university.
Yes, sure. And now here in Faculty of Pharmacy USU, Dr. Hina is in our faculty now. Do you know Dr. Hina? Dr. Ajmalsah?
No, sorry.
From Karachi, Pakistan, from ICCDS.
Oh yeah, Dr. Hina. She is faculty at your she is adjunct professor, right?
Yes, maybe next year with
For
you.
how long? Yeah, I know, Dr. Hina. For how long she will be there?
1 week because maybe she has many
Okay.
students
During
in
my
Karachi.
PhD, I have spent 2 months at ICCBS, and I know all of them. So yeah, that is very good center.
Okay.
And one of
Okay.
the international
Yeah.
Institute for Natural Product Research and try to make some linkages.
Well, Professor, we will take a picture for a while.
Okay.
Okay?
Okay.
So,
So please kindly give your brightest smile, okay? Count 1, 2, and 3. Thank you, Professor.
Okay. Thank you, Dr. Ajmasya. Thank you very much.
And then secondly, a certificate of appreciation is given to Apotheker Lista Rimayani Nasution as from MSc as the moderator of the session. We are also pleased to have Apotheker Mariani to deliver the certificate.
okay, so I can leave now?
Yes, Doctor.
Okay, Dr. Miss Rima, congratulations as your moderator today. Thank you very much for your.
Congratulations, Lisa. You should speak loudly, huh? Next time you should speak loudly.
Yes, yes, sir. I'm sorry. Okay, thank you, Miss Mariana.
Yeah.
All right, we will take a picture. So please kindly give your best smile. Count 1, 2, and 3. Thank you so much.
Thank you, Helen.
All right, before we jump into post-test, let us do the documentation for all the participants, the moderator, and also the speakers. Please open your camera and get ready. Let's open your camera and give your best pose and your brightest smile. All right, there are 5 slides here. Let's start from the first slide. Count 1, 2, and 3, smile. Next, the second slide. Count 1, 2, and 3. The third slide. Count 1, 2, and 3. The fourth slide. 1, 2, and 3. And then the last slide. 1, 2, and 3. Thank you, everyone. All right, so after the lectures, can you guess what we have next? Yes, as I said, the post-test for the second day. So dear participants, please get ready for the post-test. Please remember, all participants are required to submit the post-test as one of the requirements to get an A certificate. You can also do it by clicking the link that was shared by the committee in the chat room. You can do the post-test now. Once again, the link is accessible until 6 p.m. Western Indonesian time. If you have any problems, please approach our committees in the participants group. Well, by finishing the post-test session, we have done all of our agenda for the day. Therefore, it's time for us to bid farewell today. I really appreciate everyone's enthusiasm and cooperation. Let's keep this momentum going until the summer course concludes. We'll wrap up for today and meet again tomorrow at 8:30 a.m. Western Indonesian time. See you tomorrow on the third day of the International Summer Course of Pharmacy 2024. Goodbye.